Objective 1.2, solving quadratic equations by factoring. So this is again something that you should not only be familiar with from your first time through Chapter 1, but you should also be familiar with from Algebra 1. So we're going to go through this pretty quickly as just a reminder. I'm going to show you some methods that you can use. You maybe already have similar but slightly different methods that work for you. As long as they work and you're confident about them and you get the right answer 90% of the time, I'm not asking you to change your methods. Just make sure you show me what you're doing on your paper. But if you're someone who's still just a little bit shaky, or maybe you're not confident in the method you're currently using, then maybe one of these methods is something that might help you to become more accurate. Alright, so our goal for today is to be able to solve quadratic equations by factoring. And notice here, that the difference between this statement and this statement is whether we have an a value out in front. So here we're assuming we're talking about quadratics that have a 1 as a leading coefficient, and here we're talking about quadratics that have something other than 1 for the a value. Okay, and the process for those is a little bit different, so we need to pay attention to whether we have a 1 out in front or something else. Alright, so a little bit of vocabulary for this lesson. Polynomials can have specific names based on how many terms are in the polynomial. And so using common English prefixes, we can tell that a binomial is one that has 2 terms. A trinomial is a polynomial that has 3 terms. And a monomial is going to be a polynomial with just 1 term. So as you look at definitions and you listen to teachers and professors talk about quadratics and polynomials and what you have to do, when you hear words like binomial, trinomial, monomial, you need to know what they're talking about. And it's all about how many terms are in the polynomial. You also see there a definition for factoring, which can be used to write a trinomial as a product of binomials. So that's where that phrasing is coming in here. We've got a trinomial, which is a quadratic with 3 terms, and when we factor, we're trying to rewrite it as a product of 2 binomials. So 2 sets of parentheses that each have 2 terms in them. You can see there again our definition for the quadratic equation in standard form, which we saw last lesson. And they're telling us that zeros of a function are the same thing as the x-intercepts if we were to graph the function. They're also simply the values of x that would end up making our function equal to 0. Okay? Alright, so here's our first example, and in this example we're using a quadratic in standard form that has a leading coefficient of 1. So the first thing we need to do is to factor the quadratic expression, and when we have an a of 1, then it's a pretty easy task because all we have to do is to look at factors of c that will add up to b. So identify the c and the b. Our c in this case is the 24 and our b is the negative 14. So if we list all of the possible factors of c, including both positives and negatives, well, notice here I didn't include positives because I know if I have to add up to a negative number but multiply to a positive, that can only happen if I'm using 2 negatives. So I really only looked at the negative factors of c. And now if I add up each of those, I can see that the negative 2 and negative 12 are the factors that will give me the sum of negative 14, which is my b value. So all I have to do then is use the factors of c to set up the factors of the polynomial, of the quadratic. So a -2 means one of my factors will be x minus 2, and a -12 tells me my other factor will be x minus 12. So if I replace the standard form now with the factored form and set that equal to 0, I should now be able to come up with my answers because I have a property that tells me that if I am multiplying two things together and I get 0 as an answer, then one of those two things had to be equal to 0, or possibly both of them. So because I now have an a, which is the x minus 2, and a b, which is the x minus 12, I have these two factors being multiplied together that's giving me 0 for an answer. I know that either the x minus 2 had to equal 0 or the x minus 12 had to equal 0. What I don't know is which one, so I have to solve for both. So I add 2 to both sides in the first equation to get x equals 2, and I add 12 to both sides in the second equation to get x equals 12. So there are two possible solutions to my equation, and those are an x value of 2 and an x value of 12. Now we always want to check our answers when we're factoring and solving, and so we always go back to the original form of the equation to substitute our values in. So I go back to the x squared minus 14x plus 24 form. I substitute 2 in for x, and I work it out to find out that indeed 0 does equal 0. And then I do the same thing with the 12. And again, it does work out. 0 does equal 0. All right, now in example 2, we're starting out with an equation that's a little bit different. We have x squared minus 6 equal to 5x. In order to be able to factor and then solve using the factoring, we have to get everything equal to 0 because it's called the 0 product property. It's not called the 5x product property. It's not called the 6 product property. We have to have everything equal to 0 in order for our 0 product property to work. So that's the first thing we need to do in this case. We need to subtract the 5x from both sides so that we get the quadratic on one side equal to 0 on the other. Then we're ready to go through the steps we just saw in example 1. So first we'll figure out what are factors of c, which is -6, that are equal to the sum of b, which is -5. Well, in this case, that's going to be -6 and +1. So now we can use those to set up factors. X minus 6 will be one factor, x plus 1 will be the other factor, and that's product now is equal to 0. So now with the 0 product property, we can set each factor equal to 0 in order to solve. And again, we're getting two solutions. One possible value is 6, the other value is -1. Now when we check these, we always want to go back to the original equation, because if we made a mistake in changing our equation, then we're going to be checking in an incorrect form. So always go back to the original form and substitute our values into the x's of that form. So in this case, we can see that substituting 6 does work because I get 30 equal to 30. And substituting -1 also works because I get -5 equal to -5. Alright, so why don't you try a couple now. Again, we're still just working with quadratics that have a leading coefficient of 1. Pause the video for a moment while you try these two problems, and then come back when you're ready to check your answer. Alright, So in number 1, we should be able to factor our quadratic into x plus 14 times x plus 1 equal to 0, which leads us to solutions of x being equal to negative 14 and negative 1. In number 2, we would need to subtract the 12 to the other side first to get it equal to 0. Then we can factor into x plus 6 times x minus 2, and then solve to get x equal to negative 6 and positive 2. Now, what do we do when we have a leading coefficient, an a value, that is something other than 1? Well, we have some options. One option is to check for a greatest common monomial factor, which we abbreviate as a GCMF. Another option is to use the Xbox method, which allows us to split the middle. And one other option is to do kind of a guess and check. It's an organized guess and check, but it's mostly guess and check. So let's take a look at how each of those would work. In this case, we're looking at a quadratic that has a leading coefficient of 2. We want to look at all of the terms and see if there might be a greatest common monomial factor that we can factor out of each term. So our terms are the 2x squared, the negative 12x, and the 18. As you look at these, you should be able to identify that they all have a common factor of 2. And yes, even though 2 is just a number, it is considered a monomial. Numbers, variables, or a product of the two are considered to be monomials. So 2 is a monomial, it is considered to be a greatest common monomial factor, and it can be factored out. So when we do that, we end up with 2 on the outside, and we end up with a 6x squared minus, we end up with an x squared minus 6x plus 9 on the inside of our parentheses. And that's all still equal to 0. Now the nice thing is, if our greatest common factor is just a number and there's no variable involved, then we can divide both sides of the equation by that number. Now if the greatest common factor has a variable in it, then we cannot do this step. We have to leave it out in front as one of the factors. But when it's just a number, as in our case, we can divide both sides by 2, and that simplifies what we're working with, because the right side of our equation is still 0 divided by 2, which stays 0. So now we're just looking at x squared minus 6x plus 9 being equal to 0, and now it looks like the examples we were just working on. We're going to figure out the factors of 9 that add up to negative 6, make factors out of them, and then solve each one for 0. Now in this case, each factor, when I solve for 0, gives me the same answer of x equals 3. And even though that is the case, we do not need to list the 3 twice. We just need to list it once. So this is a case where we only have one solution, and that solution is x equals 3. Okay, your turn again. Go ahead and pause the video for a moment while you work through this. See if you can identify a greatest common factor in this that will help you to factor and to solve this equation, and come back when you're ready to check your answer. Alright, so in this case we have a greatest common monomial factor of 5. And again, since that is just a number, we can divide both sides by 5 to end up with an equation of x squared plus 2x plus 1 equals 0. So now when we factor that, we end up with x plus 1 times x plus 1 equal to 0. And so both of my factors lead me to a solution of x equals negative 1. Alright, well let's take a look at this one now. We're simply being asked to factor 2x squared minus 7x plus 3. Notice we are not asked to solve because there is no equation to solve at this point. We cannot solve expressions. That was something that caused some of you some trouble on the first test. The question asked for a factor and some of you were trying to solve it as if it was equal to 0, but nothing in the problem said it was equal to 0. So you have to pay attention what the question's asking for. So in order to factor 2x squared minus 7x plus 3, one of the things that we can do is to again look for a greatest common monomial factor. The problem is that when we look at 2x squared, negative 7x, and 3, there is no common factor in those three terms. So we need another approach to factor the quadratic because we're not going to be able to get rid of the 2 to change it into something like what we've been working with. So one approach is a method called splitting the middle. And sometimes I call this the X box because you can use an X to help you organize what you're trying to find. So in your X, the top of the X is going to represent the product of A times C. The bottom of your X is going to represent B. So in this case, if I take A times C, that's going to be the 2 times the 3, and I'm going to get 6. So that goes in the top of my X. My B value is simply the negative 7 that's in front of the X in the middle term. So now I do similar to what I did in my previous problems. I need to come up with the factors of the top that are going to add to the bottom. So it's not just factors of the last number anymore, it's factors of the product of A times C. But we still want those factors to add up to B. So in this case, we need to use the numbers negative 6 and negative 1. They'll multiply to a positive 6 and add to a negative 7. So once we've established those two numbers, we now use them to split the middle. And so we're actually going to take the middle term of negative 7x and we're going to rewrite it as the addition of two terms that are still equal to negative 7x but written as two terms. So now we're going to have 2x squared, notice that didn't change, it's still the first term, plus a negative 6x plus a negative 1x, that's the splitting of the middle, plus the 3 that's at the end. Again, the 3 doesn't change at all. Now once you've split up the middle so that you now have an expression with 4 terms instead of 3 terms, you can group the first two terms together, the 2x squared minus 6x, and the last two terms together, the negative 1x plus 3. And then from each group, you want to factor the common monomial. So in the first group, we have a 2x as a common factor, and when we factor it out, we're left with x minus 3. In the second group, we have a negative 1 that we can factor out. And if we factor out negative 1, that also leaves us with a parentheses of x minus 3. And that really is the key to making this work, is we need our two parentheses to match. So even though you may look at this initially and think, no, there's not really anything I can factor out of that, we need to, because if we leave it this way, it doesn't match what we get over here. So we need to factor out that negative 1 so that we get the match. Now the reason we need the match is because now the x minus 3 is the common factor in our two terms. So x minus 3 gets factored out in front, and the 2x minus 1 becomes the other factor. Okay, everybody see where that came from? So x minus 3 was now the common factor in both terms. So x minus 3 gets factored out. It goes out in front just like the numbers did before. And then the 2x and the minus 1 get put together in our second factor. So the factors of this particular expression are x minus 3 times 2x minus 1. And since that's all we were asked for, that's where we would stop with our answer. We're not going to set each one equal to 0. We're not going to solve anything out because this was not an equation to solve in the first place. Now let's try another method. We're going to use the same expression, but we're going to use a little bit different method. And I call this method the guess and check. The previous method with splitting the middle is a method that always works. It's very systematic. You can use it every time. There's not really any guessing to it at all. It's just very straightforward and very systematic. So for people who like that, who like to just know what to do and do it, splitting the middle is your method. But there are also people who can kind of look at these and just figure out what the right combination is. And so if you're that type of person, then you're probably going to do more of a guess and check kind of method. And so here's how that works. I start by taking the first term, which is 2x squared, and I think about what would be factors that would give me 2x squared. So in this case, we're pretty limited. 2x squared is pretty much going to be 1x times 2x. And each of our factors here needs to have an x in it. So we can't make it like 2x squared times 1 or anything like that. So 1x times 2x. Then I do the same with my constant. So in this case, my constant is 3. And pretty much I'm going to need some combination of 1 and 3. Now because it's a positive 3, I could go with 2 positives, or I could go with 2 negatives. And I'll have to keep that in mind as I guess and check. Now what I want to accomplish is that when I multiply across diagonally, I want to end up with 2 terms that when I add them together I get the middle term. So as you can see in the first setup here, if I take the 1x times the 3 and get 3x, and if I take 2x times 1 and get 2x, when I add these together, I get 5x. That does not match my middle term. So, I need to try another combination. Maybe I just need to make those negatives. So I can try -1 and -3. When I cross, nope, those end up adding up to a -5x. Okay, well maybe I need to change the order then. So I go back to my 3 and my 1 and I change the order. Cross, I'm getting closer, but this is a positive 7x. So what happens if I make them both negatives? Now when I cross, we can see that we get the -7x that matches our middle term. So once you get the right combination, then what you look at is the lines going across. So here is one factor of x minus 3, and here is a second factor of 2x minus 1, which is exactly what we got with the split the middle method. So either way works. It's just a matter of what you feel more comfortable with, what you feel you can be more successful with, and what you prefer in the long run. Now, if this had been an equation equal to 0, then just like with our other problems, once you get the factored form, you can set that equal to 0, and you can solve each one for 0 to get x equals 3 and x equal to 1/2. But that's only if you started out with an equation in the first place, and only if you were asked to solve it. All right, so give this one a try quick. We've got 3x squared plus 2x minus 8 equal to 0. Use whichever method you feel more comfortable with. Figure out your factors, and notice this is an equation. You are being asked to solve it, so you do want to figure out what the x value should be equal to. Figure those out and then come back and check your answer. Alright, so in this case you should end up with factors of 3x minus 4 times x plus 2 equal to 0. And that leads us to solutions of x equal to 4/3 and x equal to negative 2. Alright, finally, I know people don't like to memorize these special patterns, but if you can memorize them and if you can recognize when they happen, they're like shortcuts. You don't have to go through the work of figuring out factors of something that add up to something else and trying to figure out what the factors end up being, what the binomial should end up being. You can simply use the pattern to get the factors that you want. So it is worth a little bit of effort to memorize and recognize these patterns so that you can use them whenever possible. Basically, the patterns come down to when you have a difference of squares and when you have a perfect square trinomial. Okay, if you need to, pause this video for a minute, make sure you're writing this down, make sure you're studying what the pattern is, and really try to kind of get this into your head so it can help you with problems. So let's actually look at a problem here. We have 4x squared plus 12x plus 9 equal to 0. We want to know, does this really fit the special pattern? And so we start by looking at the first and last term. Each of those needs to be a perfect square. If they're not, then it doesn't fit the pattern. We have to go back to the other methods. But in this case, they are. 4x squared is a perfect square, and 9 is a perfect square. But that's only half of the check. Then we have to check out the middle term. So, if we consider that the 4x squared is like the a squared in our pattern, and the 9 is like the b squared in our pattern, then the 12x should represent the 2 times a times b from our pattern. And we need to check to see if that really works. So if a squared is equal to 4x squared, then that would mean a is 2x. And if b squared is equal to 9, then that would mean b would have to be 3. So taking 2 times a times b means we're taking 2 times 2x times 3. And if we multiply that all together, we really do get 12x. So, since everything does seem to fit our pattern, we can now use the pattern to get our factors. It's simply going to be 2x plus 3 quantity squared. And if that's set equal to 0, then we can just set 2x plus 3 equal to 0 to get negative 3 halves as the solution. Now that may not sound simpler at first, but as you get more comfortable with this and as you get used to what you're looking for, you can be doing this in your head to check everything out, and when it works, then you can go straight to your factors, and it really is a shortcut to your work. Let's take a look at one more. Here we've got x squared minus 16 equals 0. This fits the difference of squares pattern because x squared and 16 are both perfect squares and they're being subtracted, so it's a difference of the two. So using that pattern, we can rewrite x squared minus 16 as x plus 4 times x minus 4, set that equal to 0, and we get solutions of negative 4 and positive 4 for x. Alright, go ahead and give one a try. We've got x squared minus 14x plus 49 equal to 0. Try to use a special pattern to make the factors that you need. Give it a try and come back when you're ready to check. Alright, so in this case, we end up with x minus 7 quantity squared. That equal to 0 gives us a solution of x equals 7. Alright, that's it for this lesson. You've got lots of different methods for solving and factoring quadratic expressions and equations, regardless of whether you have an a of 1 or an a of something other than 1. So when you are doing your homework in your practice for 1.2, you will have your choice of methods to use based on the type of equation you're being given. Always look for those greatest common monomial factors first to make things easier, but if they don't work, then try one of the other methods to get your factors and to ultimately get your solutions. Make sure you're finding resources to answer your questions as they arise, and don't forget to check your answers on Canvas to see that you're on the right track. And that's it for today. We'll see you next class.